Okay, today a fairly short note on properties of vectors. And so here's some properties that you can use whenever you're doing vector algebra. And the properties are so nice. They are properties that you'll be used of, and that vectors will behave the way you hope they would in most cases. And today, in all cases. The weird cases we'll talk about later. For now, commutative property of vector addition. If you got A plus B, you can just do B plus A. You can add them in the other order if it's convenient for you. The associative property of vector addition, A plus B plus C. If a question wants you to do add A plus B first and then add C, well, you can do it in the other order, the same as you always could with numbers. You can add B plus C first and then add the A later. And distributive property is in. We can use the distributive property. If we've got a scalar out front of two vectors, that's a scalar out there, then you can distribute it in onto the two vectors like you always did. Now, moving forward, when there are nice videos on the internet already created that do exactly what I want, then I will use those to explain parts of the lesson. It's the only way I'm going to be able to keep up with videos, I think, along the way. So I'm going to try to use the resources that are out there when I deem them to be excellent. And I have found here a nice video that proves the commutative property on vector addition. So see video on D2L. I've linked it there. It's another YouTube video by another person there that has done a great job of proving the commutative property of vector addition. And to be honest, the proof is not something that you're responsible for on any tests or anything like that. So it's more for your information. The construction that he does will help you when you're doing some questions and so on, but you're not responsible per se for that commutative property. Also, the distributive property, and you'll see the video on D2L. Same guy does a great job of proving the distributive property of vector addition. So check those out. I'm going to do a lot of research over the next little while to watch for other places that have great resources there. So I encourage you to watch those now so you see what goes on there, so that when you come back here, you've got those in your pocket. The great news is that this works just like we would expect to. If I just put this question up, simplified the expression, and you see the expression there, before stating these properties were true, you probably would just use these properties. And the first property you'd use would be the distributive property, which we just said is in. You can distribute scalars over vectors just like that, and I get 3 times vector A plus 12 times vector B minus 15 times vector C. And then the -4 also distributes. It's a scalar out front of a bunch of vectors, so you can distribute -4 times A, -12 B, -12 vector C. So you may be completely surprised that life is that easy, but it is just that easy when you've got scalar in front of some vectors. Now, the other property that I'm going to use here is the associative property, which allows me to add these things in any order I want. And so the order I'm going to choose to add these in is I'm going to take the 3A and subtract the 4A, and then I'm going to take the 12B and subtract the 12B. Interesting, something coming up here. And then -15C, subtract the 12C. And technically what I'm going to use is the distributive property in reverse here. You might not think of it that way, but that's really what you're doing when you add like terms like that, is you're using the distributive property but in reverse. So what I've really got here is 3 minus 4 times A. Somebody's distributed that stuff. And then here, 12 minus 12 times B, and hopefully you see what's about to come in that situation here. And then the last one, -15 minus 12 times C. And maybe you don't even need that step, and maybe that step just confuses the issue. 3A minus 4A is -A. 12B minus 12B is the 0 vector. And -15 subtract 12 is -27C. So if that step in between confused you at all, that was more for technical uses the first time through, to see that I'm actually using the properties up here. I'm using the distributive property, but in reverse. If you're really with it, you notice I've used another version of the distributive property, but that's not really what this lesson's all about. And just like regular algebra, there's no reason to write that 0 vector in there. Adding a 0 vector to other vectors doesn't affect them, so my final answer there is -A, subtract 27 vector C. Sorry, negative A vector minus 27C vector. So after that example, maybe you're underwhelmed. You're like, so that's it? We just do what we did with regular variables and regular numbers? And the answer is a total yes for these properties. There's something coming where the rules aren't the same as what we're used to. So get ready for that in your brain. Go, okay, these ones are good. Enjoy the time where it's like, oh, this works just like I expected, because there's some stuff coming later where it doesn't necessarily work the way you might expect. So anyway, some more properties that came up in the middle of that. A vector plus the 0 vector equals the A vector, so adding the 0 vector does nothing. I used that in that example. And I use this distributive property technically is that, that's the one I actually used in reverse there, was that you can distribute a vector over two scalars as well. You got two scalars out front. Each one of them can be multiplied by that vector separately. And this other one, the associative property for scalars, is that if you've got m times na, you can multiply those two scalars together. So for instance, 3 times 4b, I use that in this question, is equal to 12b, and that rule's totally in, totally allowed. We don't prove it here. We just say, yep, go ahead and use that. Okay, so for your own sake, check out those other two videos that prove these things, and he does it geometrically, and they're very nice proofs. Follow through on those, and then attack that homework. Great stuff. Any questions, certainly let me